Alright, now let's have a look at this one. So still using very similar idea, we try to do the sign diagrams for f dash of x and f double dash of x. So for f dash of x, the critical points can be seen from the graph above. You have a 0 there, which is a critical point, and by looking at the graph, that is a -3. And you have another one here, and by looking at the graph, that is a 2. There's another one here, and that is a 6. And by looking at whether the graph is below or above x-axis, you can figure out this is negative because it's below x-axis, that's positive, that's negative, and that's positive. This is a sign diagram for f dash of x. Then we sort of try to do the same for f double dash of x by figuring out where the 0 or the critical points are for the f double dash of x. And those points occur at the stationary points of the f dash of x. So that will be, I will be having 1 point there. By looking at it, that looks like a -1. And then I have another point at this place, and that is a 4 there. As you can see, I try to align them with the original scale I have there in the original graph, so that later when I try to sketch it back to the original graph, I will be able to, it will be easier for me. Now, I'll try sort of map the shape by looking at these signs here. I know that my graph should be going down and then going up. There should be a local minimum at -3. And then it's going up, going down. There should be a local maximum at x equals 2 and a local minimum at x equals 6. And then by looking at the curvature, I forgot to do the signs, haven't I? Okay, the f double dash of x, you look at that, when x is smaller than -1, what you can see is the graph, the f dash of x is going up, which means that is a plus. And then this is going down, which means it's a minus, and that is a plus. Then we can start to do the diagram. We can, when second derivative is a plus, that means I have a convex, and then I have a concave, and then I have a convex. So this is what the graph looks like. Now I'm going to try to map this back now. So according to this graph, my original graph, my original f of x, should be going down in a convex nature. Okay, so it will be going down, it will be going down, and then it will reach a local minimum at x equals -3, like that. And then it will start to go up, still maintain that curvature, still convex, until it's reached x equals -1. And then at that point, it's changed its curvature into a concave, and then it keeps going up until it reaches a local maxima at 2. And then it starts to go down because it's a negative, but it's still having that concave curvature there, and it will go down, keep going until it's reached that 4, x equals 4, where it's changed its curvature into a convex, and then it's going to reach the local minimum at x equals 6, and then it starts to go up, and then it's still having that convex curvature there. So this is what the graph sort of looks like. And again, as long as you get these key points right, stationary points corresponding to these 3 critical points on the f dash of x, and then you have these points of inflection corresponding to the critical points on the f double dash of x. You got those features right, then your graph is right.